Chapter 1, Lesson 6 of Pre-Calculus, looking at graphical transformations, and we want to look at vertical and horizontal stretches and shrinks in this video. We looked at translations, and we see that a translation affects the equation of the function by adding a real value to the x or the y coordinates, whether we move it right, left, or up or down. And moving that graph doesn't change its shape. It's just like taking an item and moving it from one place to another. However, when we're looking at stretches and shrinks, we're going to multiply the x or y values by this number or by a number, and that's going to actually affect the shape. When you stretch or you shrink something, it actually affects the shape of it, and it's not as simple as moving it like we are when we're doing translations. So if we take a positive real number, and this is a very important note to make in your notes as you're listening. Stretches and shrinks are always positive real numbers. Now sometimes we have a negative number in front of a function, and we just talked about in a previous video what that negative sign means. The negative sign is actually reflecting the function over the x-axis or over the y-axis. And the number that we now put in for the reflection is going to be a positive number. So when you're identifying the stretches or shrinks, just make a note that the negative sign is not part of the stretch or the shrink. The negative sign is the reflection over an axis. So a horizontal stretch, and a horizontal is moving right or left, which is the x-axis, so it makes sense that we're going to replace all of the x values with x over c, c being that positive stretch or shrink. The vertical stretch is going to replace the y values with a y over c, and again the c value being that positive number that's a stretch or a shrink. Now if it's a stretch, the number that we're going to use is going to be bigger than 1. If you think about multiplying a number, how can you make a number bigger? You multiply it by a number greater than 1. How do you make a number smaller? You actually multiply it by a number between 0 and 1, or multiply it by a fraction. So if our c value is a fraction, then it's going to be a shrink. You're going to be making it smaller. If the c value is a number larger than 1, then it's going to be a stretch. Okay, so let's look at horizontal stretches first. We just said that we're going to replace all x values with x over c. So if we're given the function x cubed minus 16x, what would be the equation, or how would the equation be affected if we're going to shrink this by 1/2? Well, remember, if we're going to shrink it by 1/2, we're going to replace every x with x over c. So if I put x over c, that's x over 1/2. Now, we don't want to leave a fraction in a fraction, so we simplify this fraction, and that simplifies actually to 2x. Now I want you to notice something. Doesn't 2x look like you're multiplying something by a number bigger than 1? And it may appear that way, but again, this number came from x over c. So if we want to determine c, we have to think about this as being x over some number. Now when you do x divided by 1/2, divided by means you multiply by the reciprocal, which that is where the 2x comes from. So we're going to replace all of the x's with 2x. So we're going to put 2x in here for this x, we're going to put 2x in for this x, and when we simplify it, we're going to get 8x cubed minus 32x would be the new equation for a function, or this function that's been shrunk horizontally by a factor of 1/2. Alright, so let's take a look at a vertical stretch. In a vertical stretch, we talked about replacing the y value with y over c, c again being the stretch or the shrink. Now, as with translations, the vertical stretch rarely shows up on that left side of the equation. You remember when we replaced y with y minus c, we then solved the equation for y again, which moved it to the other side, making it adding the same thing as the stretch or the translation. And much like that vertical translation, a vertical stretch is going to be the same thing. We're going to end up replacing y over c on the left, but if we resolve this equation for y now, we're going to end up multiplying both sides by c. So, oh, that doesn't look too good. Let me fix that real quick. Right about there. Okay. So that means we're actually going to multiply the entire function by this value that we're stretching or shrinking by. So we're going to multiply the entire function when we're doing vertical stretch by that C value. So that kind of explains the nuts and bolts. Let's do an example. Let's take that same example we had before, and this time we're going to vertically stretch it by a factor of 3. So that would be y over 3 on this side, but then to solve it for y, we're going to multiply both sides by 3. So what we actually end up doing is multiplying the entire function by the factor of 3. So that's going to be 3 times the entire function. So we distribute the 3 and we end up with 3x cubed minus 48x. So that's kind of the mathematics behind it. I think I'm going to stop the video there, let you chew on that for a little bit, and I'll do a subsequent video where I'll actually do a number of examples. So you can check that out if you need some help with these vertical stretches and vertical and horizontal stretches as well.